Hello, we are going to show you how to use StatCrunch to handle a chi-squared goodness of fit problem. Excuse me. A goodness of fit basically says we are trying to see if a collection of data that we have matches what we are expecting. You can see I have a question up here on the homework from section 10.1. And in this particular question, I'm going to sit down and I'm going to ask you to look over the table in the top right here. Basically we got a collection of responses. Now, the claim is at the 5% significance level, test the claim that homicides in the city are equally likely for each month. So we're assuming every month has the same number. So our HO would basically say homicides occur with equal frequency, and our H1 or our HA says that there at least one month is different than the other. Now, we already have our statistics right here. We already have our p-value, so we know what we're looking for. But now we need to figure out how to get those values. So you can see our little symbol right here is here. So we're going to open this up in StatCrunch, and I am going to get my data. And we have our data right here. I'm squeezing it down so I could still see everything else on the screen. You can see I have my month, and then I have my information for each month. So now I'm going to run the hypothesis test. I'm going to go to Stat. I'm going to go down to where it says goodness of fit, and I'm going to go over to a chi-squared test. So now this pops up, and the observed column would be the numbers that I got when I did it. So the observed columns is what I found out. So that would be the 37, 30, 47. That's the numbers that are over here in this table in the top corner. So I'm going to click the column said number. Now, as for the expected column, we're sitting down and saying, what is it that we expected to happen? Well, I don't have any other column. I didn't have any expectations specifically about what to expect other than everything should be the same. So we're going to click all cells in equal proportion. That's basically saying we expected all of the months to be equal to each other. So I just come down here, I hit compute, and I should get my values of what I had. So right here you can see that I have a chi-squared of 10.37. That's how I get the 10.37 over here. Then I have a p-value of 49.72. That's how I get my p-value right there. And then I just need to make my conclusion. And since my p-value is 49 and my significance level is 5%, I'm going to fail to reject the HO, and there is not sufficient evidence to warrant a rejection of the claim that they're equal. Okay? So that's just how you would run the test. Again, very quickly here, once I had all my information imported into StatCrunch, I went to Stat, Goodness of Fit, chi-squared, and when everything was going to be the same, when we expect every month to be equal, I clicked all cells in equal proportions. But sometimes you don't have cells in equal proportions and things are going to be different. So we're going to show you a quick example of how to deal with that type of problem. So let me close out StatCrunch. Let me come to question number 5 on this particular homework assignment. What we can see here is I'm going to randomize this. We can see that I have a collection of results from a survey. And in my survey, I have 200. I'm going to keep going until I get the problem with a 200 because that'll make our life easier to show you what I need. Let me keep clicking. Of course, it's not going to happen, so cleverly delay. Of course, I need a 200 and the answers, since that's taking a second. We're going to pause. You know what? We're going to go with 201. We're close enough. So what we're going to end up doing is we're going to end up taking a look at this particular one, and we got a collection of responses that we had to a survey. Well, this is what we were expecting. This is what adults thought. Adults thought of the pie chart. So the pie chart shows the distribution of opinions of parents on whether or not college is worth it. Well, the chart up here shows the opinion of the students and whether or not they thought it was worth it. So 54% of adults thought that college was worth it, but yet 88% or 88 total students. So I need to get these either into both percents or I need to get them into both into actual value. So what I'm going to have to do is I'm going to have to do a little bit of translating. I'm going to open this up in StatCrunch. So now that StatCrunch is showing up, this is the frequency. This is what the students thought. So I'm going to change this to the word students. Now I need to come up with what the parents were thinking. Well, the only information I have is that I have parents, at 54% of the parents thought that they would strongly agree. So if I asked, or actually, instead of, we're going to say expected. So I expected 54% to say strongly agree. Well, out of 201 teenagers, I wanted 54% of them. So I take 201 times 0.54, and I get 108.54. 108.54. So 88 students actually answered that they strongly agree, but I was expecting 108.54. So now I need to go with the somewhat agree. 28% said somewhat agree. So 0.28 times 201 is going to give me 56.28. That's what I was expecting to happen for the. Now I know you can't have 0.28 of a person. We're just doing the straight math and saying that's what the math says I should have gotten. Neither agree or disagree is 6%. So I need to now take 6% times 201 people. So I was expecting 12.06. And I'm going to finish this up here. I got 7 and 5%. So I got 7 and 5. So 7 times 201 is 14.07. And then 5% times 201 is going to be 10.05. So these are what I was expecting. So now this is what I got, and this is what I was expecting. So what I'm going to do is I'm going to do the same test. Goodness of fit, chi-squared. This is what I got, my observed. What I was expecting was the percentages I just figured out. So I was expecting to get 108, and I got 88. I was expecting to get 56, I got 60. So now with all of this being done, I should be able to hit compute, and I'm now going to start getting my values over here. You can see my values at 54.49. 54.49 is over here. So that's how I got my test statistic. My p-value is basically 0.00. My p-value over here is 0.00. So everything is coming out to match the problem that we had. But what I had to do is I had to calculate the expected values in order for that to occur. So the difference is to sum it up for you, on a goodness of fit test, we're doing chi-squared. If everything's going to occur equally, you click the all cells in a proportion. If they're not going to occur equally and everything's slightly different, you have to have an expected column. And in this particular problem, we needed to calculate our expected values for this column because we weren't given how many to expect. We were given the following. We were given a percent, and we were given the number of people who were asked. So if 201 teenagers were asked, and 54% of parents said they would strongly agree, so to match parents and students, 54% of the 201 should match. So we had to do a little bit of math up front, but the test is very simple. Again, one last time for us just to walk through. Stat, goodness of fit, chi-squared, and then you would just have to choose your observed column, you would choose your expected column, and then you would hit compute from there. Sorry, thought I clicked it. Compute from there. I get my chi-squared, which is the value, and then I get my p-value right here, and I click in my p-value. And then once I do that, I just have to turn around and make a determination on what is going on. So hopefully that's enough information to walk you through a chi-squared goodness of fit test using StatCrunch. As always, reach out if you have any questions.